Well, hello, Lauren. This is Roger Seeger from Sarah. I can help you with this. We've got a car that is traveling at 35 meters per second. Okay, or I'm sorry, 37 meters per second. And it is traveling up a 9-degree slope. So here's our situation where we've got 9 degrees. And this is a kinematics problem and a dynamics problem because we want to know first what is the acceleration of the cart on the um, on the inclined plane. Now, I hope your physics teacher has taught you that acceleration on an inclined plane is g sine theta. Okay, and g is 9.8 times the sine of 9 degrees. Okay, and so for that, we're going to pull up our calculator. And what we have there is, as you can see, is we have 9.8 times the sine of 9 degrees. And let me make sure that we're in degree mode, and I'm not. I'm in radian mode, so I'm going to go to degree mode. Okay, and I'm going to find out that that's 1.53. Okay, and so that's 1.53, and that's the acceleration. That's meters per second. Now, once I've done this, I've got the acceleration. Now I can go to kinematics. This is dynamics, forces. This is kinematics, motion. Now, in kinematics, hopefully your teacher has taught you that there are some formulas that you can use that contain delta x, v naught, vf, a, and t. Okay, and those formulas are usually given, or you can memorize them. And the three main ones are delta x equals v naught t plus 1/2 at squared. Most teachers will let their students have these on the test. Vf is equal to v naught plus at. And finally, vf squared is equal to v naught squared plus 2a delta x. So those are our three main kinematics formulas, and they will work in any case where the acceleration is constant or the change in acceleration is 0. And so in this problem, we're going to use this table here, and we're going to ask, what do we know and what are we asked to find? Now, going down the table and reading the problem, we are asked to find the distance, or also displacement, how far, before starting to roll back. Its initial velocity, we know, is 37 meters per second. That's pretty fast. The final velocity, it says how far will it coast to before starting to roll back down? Well, it starts to roll back down when its final velocity is 0. In other words, it goes up the ramp and slows to a stop right there. And so we want to know how far up the ramp it goes. And so our acceleration, we said, was negative 1.53 meters per second squared. Now you might ask, well, how does it negative? It's not negative here. Well, if this is the positive direction, okay, that means that the acceleration is negative down here. And as far as the time, well, we're not given the time, but we're also not asked about the time either. Okay. Now, of these 4 that I'm playing with, I'm not playing with time. What formula is the one that has those 4: delta x, v naught, vf, and a? And it's the last formula. It's vf squared is equal to v naught squared plus 2a delta x. Okay. Now we can take it home. We're looking for delta x, so we're going to do some algebra on this equation. Now, I might do this too fast, but you might need to watch it a couple of times to slow it down. We're looking to solve for delta x, how far? And so the first thing I would do is I would flip the order of this, v naught squared plus 2a delta x equals vf squared. Simply reverse it along the equal sign. And then I'm going to subtract V naught squared from both sides. And so then I get 2a delta x is equal to Vf squared minus V naught squared. Then we can divide both sides by 2a. And what I get is delta x equals Vf squared minus V naught squared over 2a. And so we know that V naught, I'm going to come back over here and look at all of my formulas here, all of my information here. And V naught is 0. Vf is 37 meters per second squared over 2 times negative 1.53 meters per second squared. And so I can use, again, my calculator here. And so let me pop this up here and pop my calculator on here, and let's see what we have. So we have negative, let's see, turn this on. All right, so we have negative 37 squared, okay, divided by 2, or let's use parentheses, divided by parentheses 2 times negative 1.53. Okay. And so our answer there is 447 meters. Now, I told you that that was a really high speed there. And so that's going really fast. So, and 9 degrees is not much of an incline, so it's going to go a really great distance there. And so that's how I would do that problem, Lauren M. I hope that's helpful to you. And if you need any more help, reach out.